Hey, welcome back to Rithmetic with Ron. Today we're going to look at how do we solve single variable equations. And I'm going to show you a fun little trick that'll help you with how to think through this. Enjoy the video. Let's begin today's problem with a simple example. And we're going to talk about two principles today. The first one is, since we are dealing with equations, we have to remember that whatever we do to one side, we have to do the same thing to the other. Okay? Think of it as being balanced, like riding a seesaw at the playground, or being fair. Whatever you do to one side, you have to do to the other. The other thing we're going to talk about is when we solve single variable equations, we want to figure out what is that variable equal to. And we're going to do that by moving all of the other terms and numbers, everything else, to the opposite side. What that means is, in this example, I have a plus 2 along with the a, and so a is equal to something that makes this equation true. There's a number for a that makes this a true statement. 9 equals 9. And we're going to solve for that by moving the other terms away and getting a all by itself. So if I want to move a plus 2, I need to do the opposite. And whatever I do to one side, I do to the other. Now, these are going to cancel out because a plus 2 and a minus 2 add up to 0. And over here, I get 9 minus 2 is equal to 7. So in this particular example, all that I'm left with here is the a, and it is equal to a value of 7. Now, what if I made this problem just a little bit more difficult so that we could illustrate the other principle, which is working from the outside in? We'll do this. Minus 2 equals 4, okay? Now I have more going on here. I still want to get to a equals something that makes this true, but now the a is in the middle of a bunch of terms, and so what we're going to do is think about this problem like an onion. We have all this going on here, a 5, the a that we're interested in, and a negative 2, and we're going to start to peel it from the outside in so that we can get down to the middle, which is our variable a. How are we going to do that? Well, we're going to start by combining these two together, and 5 minus 2 is going to give us 3. So now I have an a plus 3 equals 4, and now I can remove the 3 by subtracting 3 from both sides. This is going to cancel out the 3. The same number, opposite sign, this adds to 0, and all I'm left with is the letter a, and now on the other side, 4 minus 3 is equal to 1. So the two things that we used here are working from the outside in to get down to the variable that we want to solve for. And the other thing was making sure that whatever we do to one side, we do to the other. Let's try something that uses a little bit of multiplication and is just a little bit more difficult. Okay, so in this example, I've got a little bit more going on. Notice my variable x is in the middle, and what we want to do is figure out how to move all of the other terms on the other side. Everything else is going to go over here so that we know what the value of x is that makes this a true statement. There's some number that goes here that will make all of this side equal to 3. Okay? So let's go ahead and find out what that is. I'm going to erase this quick so we can have a clear space to work. All right, we're going to do the same thing, and we're going to work from the outside in, okay? And one thing that can help you with working from the outside in is to remember your order of operations, PEMDAS. And what I'm going to focus on right now are the bottom 4, and say that multiplication and division are higher, and addition and subtraction are lower. And so this is a little bit more tightly held together, being multiplication, and this plus and minus that goes on with the 7 is an added term. It's further away. So let's go ahead and start by working our way from the outside in, and we're going to move the 7 first. Since it's a minus 7, I'm going to add to cancel it out, and whatever I do to one side, I have to do to the other. So this goes away, and I get 2/3 of x is equal to 3 plus 7 is 10. Okay? Now I've got a 2/3 times x is equal to 10. And there's two ways you can do this. You can always divide by the coefficient in front of the x. I can divide this by 2/3, okay? Now, in a different video, I cover how to divide one fraction by another. I'm not going to do that here. It's possible to do this if you like dividing fractions. It's not terrible. But there is another way that is a little bit less messy. It's one extra step. But what we can do is we can cancel the denominator. And I like this method a little better because it's a good habit to get into, looking at an equation and seeing if you can get rid of the fractions. And so to cancel out a denominator in a fraction, you multiply both sides by that denominator. Now the 3's are going to cancel over here, and I'm left with 2x. Okay, I did the same thing to both sides. 2x is what I'm left with here. On the right side, I get 10 times 3 is 30. Now again, I can divide by what's in front of the x. If there's two x's that are 30, I only want one x. So if I divide by 2, these cancel, and all I'm left with is x. That's what we were looking for, just the variable, by peeling away the layers of the onion to get down to the middle. And if you don't like onions, you can think of something else that it's good to peel. Maybe a banana, an orange, something tasty. And then 30 divided by 2 here is 15. Let's take a look at one final example.
2, parentheses, 3/4 a, minus 6, and then plus 2 is equal to 14.
Now I picked a problem like this because it has even more elements, and so we can really hone in on this idea of peeling like an onion from the outside in to get to this last variable, okay? And figure out what does a equal, okay? How are we going to do this? We're going to start from the outside, and if we look from the outside and there's something with adding or subtracting, let's go ahead and move that first. So I'm going to subtract 2 from both sides. This is going to cancel because positive and negative 2 add to 0, and over here I get 14 minus 2 is 12, and on this side I still have 2 multiplied by 3/4 a minus 6, okay? Now, this 2 is being multiplied by everything in the parentheses, and so I can actually divide both sides of the equation by 2, and these cancel, okay? Now I just have 3/4 a minus 6 is equal to 12 divided by 2, which is 6, okay? So I keep working my way in, right? We did the outside here, and then we went to the next outside, and now I'm down to this, which means that the minus 6 is the most outside, so we're going to peel that layer away, okay? Doing to both sides of the equation the same thing, and canceling out the terms by doing the opposite operation. These cancel, and I get 3/4 a is equal to 12, okay? Now what I'm going to do here is show you there's a couple things that we can do for this problem. One is to say I'm going to divide by the coefficient, very similar to how I did this up here. Divide both sides by whatever is being multiplied out front. We're going to do that here. And if we divide 3/4 by 3/4, that's going to cancel because anything divided by itself is 1. What that's going to give me is a equals, but now I have to divide this side by 3/4, and I get 12 divided by 3/4. What is that? Well, if you remember that you can write a whole number 12 as a fraction, this is still the whole number 12. But now I'm thinking in fraction form, I'm dividing by 3/4, and I can remember that when you divide two fractions, we're going to use keep, change, flip, and we're going to change from divide to multiply. This is going to be for times. And we're going to flip that bottom fraction like this, okay? Keep, change, flip tells us that when you divide two fractions, you keep the first one, you change divide to multiply, and you take the second fraction and you flip it. Now, I can say 12 times 4 is 48, and 1 times 3 is 3, and 48 divided by 3 is 16. So now I know that my value for A is 16, meaning that if I went back to the beginning of this problem and I put 16 right here, then this whole left side of the equation would simplify to the number 14, okay? One other thing I'm going to do real quick, let's go ahead and do this over here. If I took 3/4 A equals 12, just as a refresh, the other way that I showed you would be to multiply both sides by the denominator of the fraction. That's going to clear it out and make your fractions go away. The 4's cancel, and I get 3a equals 12 times 4 is 48. Does that look familiar? I had that over here. Okay, so then I can divide both sides by 3, and the 3's are going to cancel, and I get a equals 48 divided by 3, which is 16. What happens if you want to create some of these problems on your own? If you want to make these problems as practice for yourself or for someone else, maybe you're an older brother or sister, or maybe you're a parent making practice problems for your children, you can come up with these kinds of problems by starting with the answer. I'm going to take x equals 5 as the answer, and I'm going to work this problem backwards to create a practice problem. Let's start by multiplying both sides by 2. Okay, now I get 2x equals 10. And then I can subtract anything I want or add anything I want. I'm going to choose add 4. Okay, whatever I do to one side, I have to do to the other. Now I get 2x plus 4 is equal to 14. Okay, and I could take even more steps if I wanted to, but just like that, in less than 1 minute, we took an answer. You can use any variable, any number, start with the answer and work it backwards, and you can create a practice problem for someone else to work on. So today we saw how we can take a single variable equation, peel it like an onion from the outside in to get that variable solved. Thanks for watching, and we'll see you next time.